For this one, we're going to do mid-segment of a trapezoid. And so the main idea here is that the mid-segment of a trapezoid connects the midpoints of the legs. So remember, these two are the legs. And so the mid-segment is this little guy here, and each of these is a midpoint of the legs. So if EF is the mid-segment of a trapezoid, of this trapezoid ABCD, then we can say that AB is parallel to DC. So AB is parallel to DC, which makes both of those parallel to EF. Okay. And the other thing is that EF is equal to AB. So we have AB plus DC divided by 2. So this length is equal to AB plus DC divided by 2. Okay, so we're going to practice here. We're going to use the trapezoid above for questions 1 through 4. So if AB equals 14 and DC equals 26, find EF. So for this one, we're going to use this rule here. We know that EF equals AB, which is 14, plus DC, which is 26, divided by 2. Okay, 14 plus 26 is 40. If we divide that by 2, then we get 20. Okay? Number 2, if AB equals 7 and DC equals 31, find EF. It's the same thing. So EF is going to be AB plus DC divided by 2. So we're going to take 7 and we're going to add DC, which is 31, and divide that by 2. So we end up with 38. Oops, 38 divided by 2, which equals 19. So that one's pretty straightforward. 3 and 4, let's see, EF and DC. Okay, so if EF equals 22 and DC is 38, find AB. So for this one, we know the formula is EF equals AB plus DC divided by 2. So what do we know here? We know EF, so we're going to plug 22 in for EF. So 22 is going to equal AB, that's what we don't know, right? Plus DC, we know that's 38, and we're going to divide that by 2. So we're going to solve for AB. So first you have to multiply both sides by 2. So we get 44 equals AB plus 38. Sorry, my dog's barking in the background here. And then we're going to subtract 38 from both sides. And we end up with 6. So 6 is equal to AB. So that one was a little bit different just because you are filling in the EF. You're not solving for EF in this case. So let's go ahead and do number 4. We know that AB is 41, EF is 47, so we're going to find DC. Okay, so same formula. EF we know is 47, and that's going to equal AB, which is 41, plus DC, which we don't know, divide that by 2. So we have to multiply both sides by 2 in order to get rid of that denominator. So 47, let's see, 47 times 2 is 94. So we get 94 equals 41 plus DC. And then we just need to subtract the 41 from both sides. So 94 minus 41 equals 53. So 53 is what DC is in this case. Okay, so for number 5, for trapezoid PQRS, Y and Z are midpoints of the legs. So find YZ. Okay, so Y and Z are midpoints of the legs. So that's these two. We're going to find YZ. Well, so what do we know here? We know that we have PQ, which is 38, yz, which is 5x minus 19, and sr, which is x plus 14. So we're still going to use this formula here, and we can say that 38, which is this one, so 38 plus this base here, x plus 14, if we divide that by 2, that's AB plus DC here divided by 2. That is going to equal our YZ, which is 5x minus 19. Okay, so if we roll this out, then if we're going to need to multiply both sides by 2 to get rid of this 2. So we'll multiply that side by 2, multiply this all by 2, and we end up with 38 plus x plus 14 equals, so I have to distribute this in, so this will be 10x minus 38. And now we just solve for x. So if we add 38 to both sides, well, actually, before we do that, let's simplify. So we have x, we have 38 and 14 here. 38 and 14 is 52, so I'm just gonna, this would be x plus 52 equals 10x minus 38. Let's do that. Then we can add x to both sides. I'm sorry, subtract x from both sides. So if we subtract x over here, we would have, this is getting kind of messy, we would have 52 equals 9x minus 38, and we'll add the 38 to both sides. And that leaves us with 90 equals 9x. And so x is 10. So that's important, but we're finding yz, so we need to plug x into 5x minus 19. I'll use a brighter color here so you can see what I'm doing. We're going to go over here into the black. So 5x minus 19, we're just going to plug our 10 in there. So 5 times 10 minus 19 is going to give us 50 minus 19, and 50 minus 19 is 31. So yz equals 31. Okay. So for number 6, for trapezoid GHJK, L and M are midpoints of the legs. So GHJK, L, M are midpoints of the legs. That's telling you that's a midsegment. Find KJ. Okay, so we're still going to use the same formula. We know that LM, which is 25, is equal to these two added up and divided by 2. So 25 equals 2x plus 11 plus 6x minus 1 divided by 2. So let's get rid of the 2 first by multiplying both sides by 2. That gives us 50 equals, and now we can combine some like terms. 6x and 2x is 8x, and 11 minus 1 is plus 10. Yeah, that looks better. And then we can subtract the 10 from both sides, and we get 40 equals 8x. So if we divide both sides by 8, we get x equals 5. And then to find kj, this one wants kj, we just plug it in to 6x minus 1. So 6 times 5 minus 1 is 30 minus 1, so it's 29. Kj is 29. Okay, and the last one here, number 7. For trapezoid WXYZ, U and V are midpoints of the legs, find UV. Okay, same thing. We're just going to take 8x minus 3, which is our midsegment. That's going to equal W plus 7 plus 6x plus 5. And we're going to divide that by 2. Let's get rid of the 2 here. By multiplying 8x minus 3 by 2. So that leaves us with 16x minus 6. And I will, oops, look what I did. I put a W there instead of an X. Okay, we'll get it fixed. There we go. So now I'm going to combine my like terms. 6x and x is 7x, and 7 and 5 is, what is that, 12, 11. 7x plus, no, I'm sorry, 13. So we end up with, okay, can I add today? 7 plus 5 is 12, not 13. Okay, now we're ready. All right, so now we're going to combine our like terms, move our x's to one side and our numbers to another. So we'll subtract 7x, and 16x minus 7x is 9x. Then we'll add the 6 to both sides, and that would equal 18. Divide both sides by 9, and you get x equals 2. And you're looking for uv, which is 8x minus 3. So we're going to plug x in there. So 8 times 2 minus 3. So we get 16 minus 3. So that would be 13. Okay, so that is the mid segments for trapezoids. Pretty straightforward.